Okay, so without further ado, let's get moving with our third panel today. The industrialization of the ocean, unexploded ordnance clearance in the age of offshore expansion. And this discussion is going to be led by Dr. Peter Menzel, CEO of Corvus Works.
Thank you very much, Terry. So, as you may find, I'm the first non-journalist here on stage. So please be a bit calm if I'm not that perfect, right? The name of the session is the industrialization of the ocean. So we learned about the industrial deployment or removal actions of UXO, and we said, okay, now we have to industrialize the recovery of the UXO again, and which is already done by industry. And here the subtopic is UXO clearance in the age of offshore expansion, means offshore renewables, mainly here in Germany. And in this panel, we have three panelists. And I go in the order we have. The first one is Dr. Dorthe Erbs-Hansen. Second one, come on stage, please. In the middle, please. Jann Wendt and Peter Nieuwveld. So I will give you a short introduction to this. Today we talked about the environmental impact of UXO, and we all agreed already that this is a national or maybe a transnational common effort to clean up this. And the driver for this usually, or especially in this group here, is to protect our ecosystem, our environment. That's the main driver for this, but also guarantee safety to humans who are working offshore. And in the offshore industry, as you maybe know, UXO was not a topic for a very, very long time. So in offshore construction, ground-touching construction, for a long time, UXO was not a topic. But with improving technologies within the last years and increasing awareness, we came to a really to huge efforts, especially during the expansion of the offshore renewables. So starting with the offshore renewables in the North Sea, we started thinking about UXO and the impact of UXO, not on the environment, but mainly on working actions, on humans working with the machines there. And so due to this, during the last 10 to 15 years, a kind of, I call it kind of whole industry was grown. I know that's not correct, but really a market was made up, which was mainly driven by the renewables, but also by shipping authorities who wanted to make shipping waterways safer. New survey technologies have been shown and have been developed, especially during ESCCP and Ceridwen. We have seen a lot of survey technology being developed now here in Germany, like SubTem or UltraTem or EBOS or drone-based things, which have been developed in US, which are now coming also to Europe. We also have our own developments here, but what I see is a lot of things were developed in US, and also new clearance technologies were deployed, like multi-tool crawler and so on. And as a conclusion, I would like to give very first that since 2021, when we've been here the first, oh, sorry, no, since 2021, our industry solutions are now available, so we can remove UXO. We're doing it every day, and we, in general, can do this, and this has not changed since 2021, when the first Munition Clearance Week took place. So what is missing still, and this we will discuss today, who's responsible for the cleanup, and who has to pay for this, and is it the companies who are doing offshore constructions, or are these the authorities, and if authorities, which authority, and who's responsible, means who says you have to do it, or you don't have to do it, and who is assessing the risk for the environment, the risk for the workers, on the offshore construction side, or the risk for the infrastructure, civilians. So these are things we will discuss in this panel here, and where to start clean up first. We cannot discuss this, but maybe we come to conclusions. And we have seen that Mecklenburg-Vorpommern has a solution for this now. They will coordinate everything. as it is written in the coalition agreement. And I expect that, or what I expect, to be honest, that nobody really knows all the answers to my questions. But now I like to come to the structure of this session. We have 3 presentations, each one 10 minutes. I look on the watch very exactly. And we have then 40 minutes afterwards for discussions, and I hope you all have a lot of questions and maybe also ideas how to improve this. And we come to our first speaker, which is Dorthe Erbs-Hansen. She is a PhD in marine geology from the University of Aarhus and was working in the offshore industry, offshore renewables, for the last 12 years for companies like Vattenfall, Ørsted, TenneT. And her focus is on UXO risk assessment survey and UXO inspection and EOD campaigns. And her personal goals here, I now read it, is always to push the industry to more reasonable risk mitigation levels. So she also published a lot of scientific paper, and today she's here as a founder and CEO of Ceridwen, correct? And the title of her presentation will be Managing UXO Risk in the Accelerating Pace of Ocean Industrialization. Dorthe?
Yeah, thank you. Yeah, and presenting on behalf of TenneT, I should also say. Great, my slides is on the screens. So I think we're moving a little bit away from what we've been discussing this morning with clearing of dump sites, and now we're more moving into clearing construction sites for offshore construction. And in Europe, we have quite a lot of green or renewable energy installed in the oceans, and it's only going to get worse or better, depending on how you see it. But with the ambitious goals of the EU, the goal is to install around, 350 gigawatts of energy by 2050. And right now, as of 2024, we have 37 gigawatts installed in the waters around Europe. So it's quite a lot of construction that we'll have to do offshore. And TenneT is a big part of that, of course, because TenneT is one of the 3 German TSOs installing the grid infrastructure, getting all the power from the wind farms to land. And part of that is, of course, then also managing the UXO risk, and that risk in offshore construction project is mainly related to human safety. Is there a chance that these UXOs detonate if we touch them and then potentially kill someone on our construction site? We, of course, don't want to do that. In TenneT, we have collected all of the mitigation efforts and strategies and how we're dealing with that in an internal project that we call PARIT. It stands for Proportional Approach for UXO Risk Mitigation. And it's very much a project to increase the overall safety on every construction project. It's TenneT's responsibility as the developer to ensure that everyone comes home from work safely. And we know, of course, that UXOs can detonate offshore, and we want to avoid that. But what we also know is that we do find UXOs quite a lot in the North Sea. We also know that every time we found them, we find one, it does not detonate. Sometimes it has detonated. We have a couple of incidents where that has happened, but there's also lots of times where we have them found in a net like this, and they do not detonate. So how dangerous is it? We want to find out. Let me just, yeah. So it's a low probability that we have any detonations if we come across a UXO with some of our equipment or a fishing vessel picks it up. Of course, we're not doing fishing, but as an example. On the other hand, it can happen, and we really want to avoid that. And that is sort of the definition of what would be called a major hazard. So it's a very low probability, but very high consequence event. And that requires extra scrutiny in the way we're doing the risk assessments. And in TenneT, that is being done by using a method called bow tie risk assessment methods. I'll not go into the details. You can Google what it is. And we find that the risk assessments being done by the industry today is oversimplified, and it assumes the worst case scenario in every instance, meaning that if you find a UXO, it will detonate and cause damage. And we think we need to look into more details about when can that actually happen, because at the moment we're spending a lot of resources, a lot of time, a lot of people offshore trying to find items and mitigate that risk and remove it. And as Mr. Dieter Goulding said this morning, previously we've been doing UXO clearance where there is no UXOs. And when we do an offshore construction project and we search for UXOs, we find very, very, very few. And we find a lot of scrap. So we want to make sure that we actually spend the resources correctly. And as I said, it's dangerous to be offshore in any way. So we also want to make sure that we are not actually exposing people to more risk by being offshore looking for items than the risk in the first place from a UXO. So in popular saying is the cure must not be worse than the disease. And that is what this internal project in TenneT is about. It's about having a very holistic view of the UXO risk at sea for our construction projects. We want to, of course, understand in detail the exposure of risk that we bring to people from UXO, but we also need to make sure that we know how much risk we expose people to by doing the mitigation measures, and also distinguish between a risk to human lives and an injury, and what is also, of course, substantial risk to assets. And that way we can also weigh better if we actually want to, if we spend money on lowering the risk for the projects in themselves, because it is critical infrastructure, so it's of course also important, but maybe we can lose an asset, but we can't lose a human life. Over the years, TenneT has spent quite a lot of time and resources on scientific studies, gaining a lot of knowledge about how UXOs act in the marine environment, how likely it is to get them to explode, what is the triggering, how can we trigger them, what if they were brand new, what if they're old. We now know they're more than 80 years old. That has changed the way that the trigger mechanism work. If you strike them, you have to strike them really hard. We also have information and modeling in the results about damage to vessels and thereby humans on the vessels. And there's a lot of information, for example, done by Peter Menzel on mobilization of items on the seafloor. Do they move? Are they in place where they were? Are they still in place where they were 80 years ago? We also have a lot of information from historical records, especially here in Germany, about where the minefields were, where the bombing routes were. So we do have information that can help us concentrate our efforts in areas where we have a higher concentration. And here I'm not talking about the dump sites, because that's a totally different topic that we completely avoid with offshore construction. And then we want to take a proportional approach, so we want to actually calculate the probabilities of, first of all, encountering a UXO, and then making it go off, and then hurting someone. That can be calculated using this information, this scientific information that we have. And then we can come up with what we would call a naked risk, and then compare it to the risk from a mitigation measure, like a geophysical survey, where you have maybe 20 people offshore for 2 to 6 months. How likely is it that actually someone will get hurt by being offshore? Just doing geophysical survey, like normal offshore work, compared to the likelihood of someone getting injured from striking a UXO. And then, of course, it doesn't make us not do anything at all, but we want to really concentrate where we have higher risks and then have procedures in place so that if the most unlikely happens, we still have a way to make sure that no one gets hurt. Of course, it's not really something that you just can, draw on the back of a napkin and get done with. So all of this information is something that's been collected for many years, and now we're putting it all together and creating a software that will help us make these calculations on a project-specific, location-specific area. So we have, as I said, a lot of information on the historical data. We have a lot of scientific information. Then we, of course, need input from an end user about which installation methods are you using, what vessel types, what is the water depth, etc. And then we have our risk assessment method. And then at the end, we'll bring out a risk assessment that will probably divide a route into sections where different mitigation measures is warranted, and then we will go from there. So what we want, my concluding slide is that we want to break the habit. We don't want to do the mitigation measure, the default mitigation measure, because it's the only tool we have in the toolbox. We want to make sure that it's actually the most appropriate method, that it actually lowers the risk, and that we are not exposing people to more risk by introducing this mitigation method. I think I'll leave it at that. Thank you.
Thank you, Dorthe. So our next speaker will be Jann Wendt. Is there anyone in the room who does not know Jann Wendt? Raise your arm. So Jann, I do not have to introduce you. Jann is the CEO of North.io, and the title of his presentation is Cloud Technologies for Managing Ocean Data and UXO Clearance Operations.
Perfect. Thank you very much for the short introduction in this way. I was talking already in the beginning, a bit earlier with Dorthe, about the topic of data. Do we actually need more data, or we need to make better use of less data for actually offshore topics and UXO clearance? So I think that's an interesting discussion, maybe also afterwards. The company, I don't want to tell you, from 2011, around 70 people and highly specialized in ocean data. But what I actually want to discuss with you is the mega trends that from our, let's say, data perspective is reshaping a bit the way of how we have to think about ocean data. So we see ever increasing trend in industrialisation, so more and more usage of the ocean, which in the end is also a part of getting more data and more information in. We see more usage of autonomous systems as well out there, also for surveying, so we get more data. We can get even higher precision data at different kind of scales as well. And we see out there connectivity. So we have the Starlinks yet partially on board, also the survey vessels start to have Starlink on board. And from a pure technological perspective, that creates actually a greenfield of technological developments if I put all this together. So from a software side, computing side, makes it very, very interesting. But with this comes data complexity. So that's also something. You pay a price for this. When we talk about data in the ocean world, we talk about a multitude of different kinds of data sets. So everything is relying on sound, so we have to know how fast the sound travels. We talk about multi-beam echo sounder data, which is point cloud data, dense point cloud data, even with backscatter data, so it can get very fast, very, very, very big. We have still the ever-increasing side scan resolution when we talk about synthetic aperture sonar systems, who are also very, very useful technologies as well. In the UXO clearance, we want to also have a look under the sediment, so we talk about magnetometer data as well, sub-bottom profiler tools, and in the end also other tools and other data sets that are upcoming. So we have a tremendous tool set of data available to work with, not even talking here about the historic data that we also see. But with this comes a lot of challenges as well. So there's on the one side the volume. Yeah? So it can reach very fast petabyte size, yeah, if we do it in a very, very high resolution. We require computing. Yeah? So it's not something that you run on a desktop anymore in 10 minutes. So it's something that gets bigger and bigger and also takes more and more time. So maybe new approaches in the cloud computing world have to be applied. So volume is one of the big complexities. Storage and processing, yeah? So we have to store it somewhere. Yeah? So it sounds simple, but it's unfortunately not that simple. Yeah? When we talk to offshore clients as well, data is scattered. There's a hard drive here, there's maybe an Excel list here, there is something there on this server, something there, and this is, in some cases, state of the art. Not everywhere, but we see it. Now that's the real world. Security. We talk about security. So this data is sensitive. And in Germany, I think there still should be maybe also a bit more debate about how sensitive this data is and how do we handle it. If, for example, the BSH is publishing data on the Pinter portal, which is raw, highest resolution data in areas where we will build infrastructure. It's a question that you can at least pose if this is a necessity to do it or to do it on a request base as well. So do you need to control this data flows in some way? You need to collaborate on data. We have a world that works remotely. So how do you collaborate on these kinds of amounts of data sets? We have multiple stakeholders in this very complex projects. We missing standards in also the underwater domain when we talk about data sets, about data formats as well. And the end also comes with quality. So data quality plays a major role in de-risking also the investment. I want, as a contractor, the quality that I asked for. How do we assess data quality? It's also a very complex process. So I think it also depends a bit on your perspective. There are maybe approaches where you can make better use of less data, maybe even also what we just heard from Dorthe. There are maybe ideas to just gather less data and do it more precise, also spend less money for it, because it's still something when we survey scrap, what you just mentioned, it's a very pricey thing. And in the end, we pay it. We pay it with our taxes. We pay it actually with our electricity bill. On the other side, maybe you also want the very, very big picture when you look from a defense perspective in this field. You need to know every single thing that you see in this kind of environment. So we are building technology in this field, ocean data platform and cloud technology to work on different kind of things there. So one big thing that we see in data warehousing, harmonization of data. Very, very complex task. Also, if we talk with the defense world about it, multitude of sensors, everyone provides data in specific data sets, formats. So this is something we have to work about and where we can also spend lots of money, but where we can save also lots of money as well. Data exchange, how do we make it available to all stakeholders? How do we do it in a very secure way, this kind of data exchange? How do we make it available to the right person in the right time as well? And how can we maybe even make use of existing data, but in a better way, if we treat it differently? So I think here's a nice example of a, let's say, classical side scan, which is very fast rasterized in a raster, but actually it has a very, very different resolution if we treat it in a big data point cloud approach. So there are very, very interesting things that can be done with technologies. And just to give you some ideas on what maybe can be done better, also for scaling operations, historic data. Can we use big data technologies for analyzing historic data? We did some first tests with it. You can also downstairs have a look at some kind of approaches, how to automatically read information from this kind of data. How do we do in a fast, efficient way object detection on three-dimensional multi-beam data sets on a point cloud level? Also there, cloud and AI developments that are ongoing provide lots of possibilities. Change. Now we want to have an understanding of what changed between status A and B, or A and C. And also there, cloud computing can play a major role if we want to do it really on a point cloud level, so on a way more detailed data set. So the data is there and it gives more information than we at the moment use. And we also see it from a critical underwater infrastructure perspective. Do we see changes like maybe a trace from something that wasn't there before? We can also go even bigger if we want to use more data. We can talk about water column data, multi-beam data, which can be also used to detect objects in the water column. We talk more about the defense case, less about the UXO case, but it's also something that we can do. And also even more reactive tasking. So react automatically on an incident, react on an anomaly, but don't do it every day, but do it just when it's there. And nevertheless, cheaper sensors. So we see also that sensors are getting cheaper, platforms are getting cheaper. There's, for example, a laser scan-based system which can work in nearshore environments, which can cover tremendous areas when the visibility is correct. But data gathering can be also cheaper and will be cheaper in the future. So good question, do we need more or do we need less data in the end? Thanks.
Yeah. Thank you, Jann. So yeah, we heard about how risk assessments are done, so how we assess what has to be done and how it has to be done. We heard that we need data for this. Jann has all the data, North.io has the data. And now the question is, how do these data come to North.io? And I do not know who made this panel, but I like this red line here. The next speaker I will introduce a bit is Peter Nieuwveld from Fugro. He has a degree in geomatics. And he started working in GIS and as a surveyor in 2001, more land-based. And in 2011, he went to the offshore part, and especially in Fugro, in the tendering processes and data, means was working on data centers. And later as a business analyst and product owner and owner of product solutions. You will maybe tell us what this is. And he currently develops Fugro's UXO risk mitigation strategy. And one of his key expertises is, as he said, innovation management. And the title of his presentation will be Applying Technology for More Efficient UXO Risk Management. Yeah, maybe, Peter, we will hear about new technology, which already was developed in the US. Thank you very much.
Thank you very much. Yeah, I'm just going to spend a few minutes talking about how we can possibly reach some of these goals that we've been speaking about already, based on the application of technologies to this whole scenario of UXO risk mitigation. I'm the one that it's not working for today. If we can have the next slide, please, that would be great. So just very briefly, a look at the UXO risk mitigation process from a commercial perspective, because we are a commercial company that I work for, and we work primarily for clients in the offshore wind industry and related infrastructure. And so we have a commercial approach to all of this, of course. And so it's a five-stage process, starting off with desktop studies and understanding what the historical risk is and how that filters into a risk assessment for a particular site and a particular project, construction project or infrastructure project. From that, we can design and execute a survey where we go and detect and map items. Any items that are deemed to be potential UXO objects will then need to be identified in an identification phase. From that, you understand which of those objects are confirmed to be UXO, and if necessary, there will be a fourth stage, which is clearance. And at the end of it all, the idea is to be able to certify that site as being ALOP certified for the particular activity that we're going to do. And ALOP is a principle I'll explain briefly, but as low as reasonably practicable for those who are not familiar with it. Could I have the next slide, please? But what's more interesting is what the costs of each of those steps in the process look like. And this is where there's a lot of discussion, really. And if you look at the first phase and the last phase, those are primarily desktop activities. So, relatively speaking, those are the smallest portion of the cost. When you start to work offshore, you start to employ vessels, lots of people, assets, and that becomes more expensive. So phase 2, 3, and 4 are all offshore activities on site, and so they carry a very large proportion of the cost. The survey itself is not the most expensive part of the process. These are not exact numbers, not based on exact projects. It's just a representation of more or less what things look like cost-wise. But by far the biggest portion at the moment, following typical offshore processes, is that the identification part of the survey is the most expensive. And that's the part of the process where you go with a fairly large vessel, a very large crew, expensive assets like ROVs. And in most parts of the world where we're developing wind farms, particularly in Europe, the North Sea, for instance, the UXOs, or the objects that we need to identify or search for, are buried. So you can't just see them on the surface. And so that involves digging holes. And so money is literally being spent digging holes in the seabed. If the clearance phase is required, that also carries a fairly significant cost as well. Could I have the next slide, please? So this is the ALARP process, literally trying to reduce risks on a site and for a particular activity down to a level that is as low as reasonably practicable. Now, reasonable and practicable are two debatable things and are actually dependent on what it is you're doing, where you are, and what the risk is that you've assessed from your desktop study initially and what you find on site. But essentially, as you put in effort, your risk comes down. That's the red line. But in order to get that risk down, you have to spend money and the cost goes up. And so ALARP tends to sit somewhere just to the right of the middle, typically in our industry, at a point where we think that there is low enough residual risk to be acceptable, and the cost is hopefully not going up too fast. But the problem is that this is not a typical UXO project cost. If I can have the next slide. The challenge in UXO projects is that cost curve is not a nice little upward trajectory. You've got a really expensive section in the middle. Back one, please. You've got a really expensive section in the middle, which actually pushes that cost curve up very quickly. And so the further you go to the right of the middle, the quicker the cost goes up. And it's not a typical ALARP project curve that you might see in other industries. And that's the challenge. That's exactly what Dorthe was speaking about earlier, that cost goes up very, very quickly. On the next slide, please. You can see that there are basically two options to mitigate this. You can either move your ALARP to the left and accept more residual risk in an attempt to not incur all of the cost towards the right of the graph, or you can try and stay on the right-hand side with a lower residual risk, but try and bring that green cost curve down as much as possible. And in reality, I think that the answer lies in both. It's a combination of both. Could I have the next one, please? So, from our perspective, we really believe that the technology landscape that has emerged over the last couple of years lends itself to solving this problem to a large extent. So the mix of technologies that we have available at the moment lend themselves to a much safer and a much more efficient geodata collection process, and also gives us the possibilities of more advanced geodata processing. Next slide, please. So when I say the mix of technologies, there are many technologies that have emerged recently. There are lots of old technologies that have been around for a long time which have improved or have been used in better ways. And I'm not going to explain all of these things. There might be some familiar topics on the screen right now for some of us. There's a few of them, though, that have become key technologies, either have been or have emerged as key technologies. So on the next slide, I'll just very briefly describe three of them. Magnetics for offshore UXO survey work has always been the primary method of searching for things. With one or two exceptions, historic ordnances are typically made from ferrous metals. There are some very key exceptions to that, but because of the vast majority being ferrous, magnetics is a key technology in that. It has its limitations. What's become more common very recently is acoustic approaches using EBOS or SBI to look into the seabed. Like I said, in the North Sea, for instance, we have a problem where lots of objects become buried over time. So looking at acoustics is now becoming a very, very relevant topic, but also emerged in the last couple of years and becoming very useful in all of this. And what Jann was talking about is cloud computing as well. It gives us the opportunity to process much, much larger volumes of data, to process things automatically to a certain extent, and to start to apply layers of technology on top of what we would traditionally do, such as AI guidance, machine learning, that kind of thing. So, as an example on the next slide, a traditional approach would be magnetics, and you might see from a magnetic survey this kind of response. That big purple blob, pink blob at the bottom is a 17 nanotesla response. In a typical sense, we would need to dig up that item to see what it is, because it fits closely enough what could be a threatening object. But if you can add in a complementary piece of data from a different technology, on the next slide, that might change the picture significantly, because now if we look at, this is an example of an EBOS image of the object which is approximately 0.5 meter below the surface of the seabed, we can start to see that that doesn't necessarily match the shape that you would expect to see of a typical UXO. And so that changes the decision, potentially in this case, to having to invest time and money for assets to go and dig a hole, to no longer having to dig that hole based on just one complementary piece of data. And so this mix of technologies and the use of different types of technology really changes the picture. Conversely, on the next slide, you might have a situation where you have a magnetic anomaly which is on your list, and you look at an acoustic image, and that goes significantly up the list as a priority to investigate, because you have a strong reflector below the seabed which fits very neatly the shape of potentially a torpedo or something like that. So even in the cases where you were possibly correct with just one data set, having another one gives you even more information and possibly changes the priority order. On the next slide, we could go even further. Adding a third complementary data set might change the picture, but in essence, it really just gives you even more confidence in the decisions that you're making as you go through this process. And the impact of all of this is that you will ultimately get to a point where you have a high level of confidence in the data assessments that you've made, and you will have a much significantly reduced list of targets to identify in the identification phase, if that's necessary. On the next slide. So what am I saying? What we really need to improve the whole process of UXO risk mitigation in this rapidly expanding offshore age is a very diverse toolbox. We need a diverse technology toolbox with lots of different options to suit different scenarios. We do need to try and optimize acquisition and the activities for each tool so that we can get the best benefit out of each of those tools. And in order to do that, we have to really understand those tools, but importantly, we need to understand the limitations of each of those tools so we know how correctly to apply them. And ultimately, we need to do what makes sense. So it doesn't make sense to add lots and lots of data, but at significantly higher cost if actually just a little bit less data makes more sense economically, but is fit for purpose for determining that risk level. So we need to think very carefully about each circumstance, each project, each scope of work, and decide what really makes sense here and which things we're going to pull out the toolbox to make that work. Next slide, please. So just 2 slides in conclusion. I do believe that at the moment we have all the technologies that we need to be effective in drastically reducing false positives. False positives basically reducing that list of potential targets that need to be dug out of the seabed to identify. And because we can reduce false positive, we will, as a result, dig fewer holes. And to quantify that, my personal conviction and from what I see available on the market and all the developments that are happening, I think that we can move false positives from, in an offshore commercial sense, from more or less 95% false positives to, I think, better than 10%. To put that into perspective, if you go out and dig 100 holes in the seabed, at the moment we would expect around about 5 of those holes to contain an object which is UXO related. But in the future, we could dig those 100 holes and only 10 of those holes would not be UXO related. So I think that the technology is lending itself to that kind of improvement, which means that we would have to dig possibly 90% fewer holes in the seabed and significantly reduce cost as a result. So on the final slide, that would bring the cost curve back down to something that looks more reasonable, meaning that we could reach that low residual risk further to the right on the graph without incurring that massive spike in cost. And that would give us a much better scenario all around. Thank you very much.
Yeah. We heard a lot of about risk, right? And Dorthe said we would like to find out how dangerous it is. UXO. And now my question, how dangerous is it?
Yeah, that's a good question. If I had the answer, I think I would be a millionaire. But we know from the information we have so far that quite a lot of force, and I can't put a real number right now on it, but a lot of force is needed to set off a UXO, and you have to hit it directly. And that is if you're assuming that the UXO is brand new. So if you add on top that it's been in the water for 80 years, it's an assessment that's needed to be made, I think.
Means, especially when we're talking about old munition, right? And we heard about data, and you said that data is one of the main input information you need. And we heard that companies like North.io are providing this data, and Fugro is collecting this data, and we also have the historical data. So means one question maybe to all of you, maybe start with Jann. What do you think is the main difference between a dumping site and the activities we have in offshore constructions? And can we adapt the methods from offshore construction maybe to dumping sites? And what are the challenges? What do you think regarding data and information on the objects? And
Test. Yeah, first, I think one of the major differences is no one pays at the moment for dumping sites. Yeah, it's not the data side of things, but I think that's the big difference. For sure, a dumping site needs to be investigated from my perspective on a total different level. So there, more or less, every technology has to apply it. It's very locally, very locally. I mean, we also see that there's more dispersed, actually, dumping sites over bigger areas, but it has some kind of local borders compared to the offshore actually surveying a part. What I find quite interesting is maybe the combination, using data more efficiently, but also maybe avoiding to collect unnecessary data as well. So that's, I think, what you proposed, Dorthe. Can we maybe, due to some smart pre-analytical steps, due to some modeling steps, due to maybe also existing data, because there is a tremendous amount of data is available in this world. So I have no idea how often each point in the Baltic Sea has been measured already, but I'm almost sure that each point is covered. So can we make use of this before we start spending tremendous amount of data, money for data gathering? And when we gather data, do it as precise as possible. Gather only the data that's really needed, verify very fast with additional technologies. And Peter, I think that's what you just said. Is it really worth actually digging out this object? So I think there's a big difference in dump site as much as possible to get a full understanding about the extent and what we are facing there, versus different kind of methods of reducing actually data acquisition and spending less costs.
so,
If I may just, I think the one thing that we can definitely learn from the clearing of the dump sites that's happening now is understanding more of the conditions that the munitions are in after 80 or 85 years in the water. I think that would be a knowledge that would be very beneficial to the offshore construction industry in understanding how dangerous it is actually to our construction activities. If it's just a piece of TNT on the seafloor with no detonator inside, maybe we don't have to find that for constructing a cable.
Yeah, maybe just a comment very quickly on the difference between the dumping sites and the offshore wind construction sites, for instance. The difference from the commercial approach is, when you're working in an offshore wind project, as Dorthe said earlier, you're avoiding known dump sites, definitely. There's too much to do there, there's too much risk, so you're just not going to incur that for a commercial development. So it becomes a problem of trying to find one or two very, very small isolated objects on a vast area of seabed. And that requires an extortionate amount of data. You've got to survey a very, very large area looking for one small thing or two small things. And so the exercise and the process is very, very different. Whereas if you're looking at a dump site, it's a very, very densely populated area of objects that are likely to be UXO. So it's a very, very, very different approach. If you find a UXO in an offshore wind farm project, it's a weapon typically that's been fired and is armed, and so it's a different risk approach for a start. In terms of actual risk, yeah, you can poke and prod them as much as you like, but I'm going to leave that to the EOD experts, because I've read the reports from 2021, I think, about the fishing vessel off the UK coast that got I think they assessed it was a 250-pound airdrop bomb, got stuck on the cable, and it blew the ship out of the water. So yeah, it's a risky thing to try and assess how sensitive these things are after 80 years, because I think there's so many factors involved in that. But it's a very, very different process when you're working in a commercial sense for a commercial project, or when you're working on a dumping site.
Yeah, so we heard, so one of the big differences is that the objects we find during offshore construction is that they are fused, right? And
that's the assumption, yeah.
Okay, so my question now is, we have also seen that there's a lot of ongoing research here on UXO and strategies. All the projects are listed there, or the partners and the projects were listed somewhere here. My question is now, if you could tell us, or if you can just call any wish, what do you think, what kind of research would be really required for remediation of UXO in industrial use? It means, what do you think, from your perspective, would be something what you're missing? Is it more technology, more data fusion, or is it more knowledge about the old objects? What, from your perspective, is the most important thing you need? So, what do you think? Feel free.
Yeah, I think knowledge about the object plays a very vital role of getting a better understanding. Yeah? So, because if we get a better understanding on the one side of the status of the objects, fused, unfused, that plays a vital role in the risk assessment. On the other side, we can also use this knowledge for training of AI, machine learning algorithms, for further reducing actually also the risk in the end. Because also in the end it's a question about how much are we willing to spend to bring the risk down. Yeah? And if I compare it, actually also tomorrow we'll also have quite some guys from the German Navy here about mine hunting. So there's also all the time the question, how much, in the end there's not time, it's not money, it's time. How much time do I want to spend to fully de-risk my route with my ships? And if I have a tremendous amount of time, equal money, then I can get to a risk of zero, which is almost impossible. But if I have only a limited amount of time, and we are in a world where we don't have overarching resources as well, and again, time equals money, we have to find the good balance of accepting, I think, is part of risk, because we will never get it to zero.
So, Peter, what do you think about this, or Dorthe?
Yeah, I think on my wish list, definitely a lot of the stuff that Jann just said, but I think I would, from a commercial side of the civil world, I would love a better collaboration with the militaries of the different countries, because they are the real experts, and at the moment we are a commercial world and a civil world trying to deal with a military problem, and we don't know everything about these weapons. And of course we can do studies and we can do scientific studies, and there is a lot of information, but the real knowledge is lying within the militaries and the navies of our countries. And if they can help on the commercial side of things also to say, this you have to worry about, this you don't have to worry about. And we already know where the mines were laid, for example. If we're just thinking about mines, I know bomb it's also there, but if we just talk about mines, we know where the minefields were, and they can help us say these mines are dangerous, these are not dangerous, these are so corroded that it's not an issue anymore. And at the moment, those assessments are done by commercial people, a lot of them, of course, with a military background, but still, I think they would really help focus our efforts if we get a much closer collaboration between the civil and the military world.
Okay, so in general, if there's any questions, I have another one, but I have 500 questions. If there's any question from the auditory, just feel free to go there to the microphone and announce your question. But you said better cooperation with military, but also maybe with other authorities, or what do you think? And another question, that we heard it during the whole day several times, if we have objects that are fused and cannot be removed immediately. And I heard it from Annika, I think, about wet storage. What do you think about this option, having a wet storage where to store objects which cannot be removed? And
so that's a good question. I briefly described the sort of the five-phase approach, and the fourth phase is clearance. Now, clearance doesn't mean getting rid of an object. Clearance means clearing that risk associated with that object that you found. And so the first option is actually just, if that object is not in a position that it causes a risk to the activities for that particular development project, you can leave it right where it is. So the first option is do nothing, leave it right there, because it's an armed weapon and you don't want to mess with it. The second option is, if it's in the way, can you actually just reroute your asset around it and still leave it where it is? And that's obviously something that our client, the developer or whoever, needs to decide. Is that an option? Can you move a monopile slightly further away so it's in a safer location and leave the object where it is? The third object is, the third option is possibly, can you move the object to a safer spot and then leave it? Is it safe to move? And then the fourth and fifth objects become options become about actually destroying the item or removing it from the marine environment altogether. The challenge we have is that you can't take armed weapons out of the sea and then transport them on shore to a delaboration factory somewhere. You actually, if the decision is through that whole process that that object is a problem and needs to be destroyed, the only way to get rid of it safely is to detonate it either low order or high order. Or, as we heard this morning, Reasura mentioned perhaps there's other options coming. That, you know, we can use chambers or things like that in an offshore manner. But at the moment, if you do need to get rid of an object, the only way to do it is to burn it.
so now I expect a lot of comments on this, because I heard 5 times before detonation is not an option anymore. But now we hear we have to detonate, maybe. So that's, yeah, Dorthe?
Yeah, again, I think it comes down to who takes the responsibility for making the decisions. And in the commercial world, we don't know what to do if we find an armed item. But if we get help from the local navy, for example, making the assessments, can you move this or not? And at the moment, it's very much up to the private sector to take those decisions and take that responsibility. And I don't know anyone who wants to say, sure, you can take that bomb and lift it up with the water. But if it can be said that it's safe to do so, I think wet storage is a great solution, because it's better for the projects. It's much faster to move the items into a basket and move that basket out of the way, and we can go on with our construction. Last time I worked with a project in German waters that needed to be an exception from the law, so there's some legislation that is needed there if you want to do wet storage. But yeah, it can definitely be an option, but making the decision if you can actually pick the item up is very difficult for a commercial company to take that decision. You need expert knowledge.
Thank you. So I see there are questions, please.
Yes, thank you. Sven Koszynski, company Meereszoologie. Yes, this discussion on lifting and shifting an object is quite an interesting one, because when you lift one object to a place which is safe for the project, it's still in the marine environment and it will still emit chemicals at some point. And so from the view of the environmental protection or of the society, this object should go out of the marine environment. But that is also something which is costly and definitely should not be at your costs, because it's not in your interest as a company. And I would like to know what views you have on this, on the cost aspect and on the societal decision, leaving the object there or taking them out. Thanks.
I think if I had to take a guess, there's orders of magnitude more dumped munitions which are not fused in the ocean than there are fired and fused weapons. So if that means that you have to make a decision to leave a fused weapon in the sea because that's the safest human safety thing to do, I think that from an environmental perspective, the effort to clean up would be far more better spent on the dumping sites. I wouldn't worry about the few items that are fused that you kind of have to leave there for safety reasons.
Yeah, I would also say that if you can leave them, for example, in one of the baskets that was showed earlier, and at some point the incinerator comes by and picks it up, that would of course be the ideal scenario, and then you actually control where that item is until you have the time to actually deal with it, but you're not delaying the construction project going ahead.
Thank you. Then next question, please.
Well, I haven't got a question, but I would like to make clear the military don't decide whether you move the UXO or whatever. There's two laws. There's public law, and there's mainly the local authorities or the waterway authorities. They decide whether you have to remove the UXO or not. And the other one is the labor law, and that's you as an employer and the contractor have to deal with the labor law, so take care that that UXO is removed out of the area. The wet storage is used indeed to carry on with your work, so temporarily lift the UXO, move it out of the area so you can carry on, and that if you have finished your project of your cable or your pipeline, that the Navy or the EOD can come in, let's say in an efficient way and detonate or handle or disarm UXO in an efficient way, because they have lack of capacity and they would like to do that, let's say 3 or 4 bombs or mines in one day and not, let's say, run 4 days in a row. So there's complete different aspects which play a role. Basically with your risk mitigation, the quality of your project is based on your historical information, a good risk assessment, a good risk mitigation, knowing what's going on. So our client must also know what they want, so we can refer to that. And then the quality is based on your survey, we call it detection, but your survey and your interpretation of the data. And yes, you want as much data as possible so you can combine, so you can fuse data, so you can exclude objects which are not let's say, of interest. They're not false positives. They're only wrongly, the interpretation is made wrongly if you don't know your threshold. So in your risk mitigation, you know your threshold, and based on your threshold and the data that go with it, you can actually see which data for you are of importance and the rest you can skip. But that asks for a different process and a different way of approaching things in this respect. But the quality is based on the first steps. And then you cut out a lot of cost and don't have to waste time on getting metal parts out which are of no interest for you at all. Yeah? But it asks and requires a lot of expertise up front to run your projects efficiently.
Yeah, so the analysis, good analysis of good historical data and good instrumentation data, means good survey data, combining this in a smart way could be a good way. But maybe in general, I talked about the drivers. Why are we doing this UXO clearance things? So in the with the starting here for the last Munition Clearance Week, the starting point was the environmental impact. Means we heard about toxicology and cancerogenic. Can you please cancerogenic? Thank you very much. I cannot. This compounds in the water, and here we see that it's not the environment. It's the main driver here is safety for workers. So these are completely different things. And the question at the end is, if we are doing dump site remediation, we also have to care about these things. I do not know if we are already done about safety for the workers. And my question now, maybe to all of you, is how could the government, with the actual approach, support the work that the companies, the industry is doing? Means you're building systems to collect data, to fuse data, as we heard, it's important. You have doing really, or you're doing UXO remediation actions offshore, and you're developing systems who can do this. So here are the companies, the industry who could do it and who know about it, who is doing it since 10, 15 years. And the government now is planning to do it. The question is, how or what are you expecting from the BMU? How could they support you, and how could you support maybe the government with your knowledge? Jann, maybe?
Can start. So from, let's say, our perspective, standards would be great. Yeah. So and also legal frameworks would be great. So at the moment, when we also again have a look, for example, at critical infrastructure, we are still waiting for the Kritisches Dachgesetz, so the law which has to be actually European law, which has to be ratified in Germany. And we need some guideline to act against. And also, otherwise, I think every project is specific. That's out of question. And for sure, you can spend a tremendous amount of money, and you can spend also less money and even less money. Yeah, but it's something which, at the moment, from my perspective, we are missing a bit some kind of guidelines, which also maybe have to develop together with industry. So it's not something that government will just come up like this, because they also don't have the expertise in this. To be honest, I mean, they have the bomb disposal units still. But this is something what is still missing. I mean, we had, for example, a European Union project, so-called BASTA project, together with the GEOMA, where we developed quality indicators for data. So very quantitative indicators with industry. I think that you also provided. I think Peter, you also provided information. It was a very, very good project with very good outcomes. Even we had scientific papers published in magazines about it, but it was never uptaken. It was never taken into some kind of processes as well to use it in some way. That's honestly a pity when there is efforts, when there's money spent from European Union research money, when there is spent time from also industry, which is also very valuable time, and something is developed, but it's never put in place. So and that's where I really hope that in the future maybe there's a better cooperation. Taking this kind of research results, we have a transfer problem here, at least in Germany and or Europe, but yeah, provide clear guidance based on what was already done and use these results more efficiently.
Yeah, I think you're absolutely right. Coming back to for example, the wet storage. This was, for example, the first time I today heard that was actually considered as a viable option. I think what we really need from authorities is an easy process to manage the UXO risk on our projects. Of course, first of all, finding out where and how to mitigate the risk, but then also if we then actually do find something, how do we deal with it in a timely manner that does not delay the project? And if it is the last resort, a blast-in-place operation, I know there are already requirements there, but it's still a fairly lengthy approval process. So that can delay a project. And if we're accelerating the infrastructure we're building in the sea, we also need to accelerate the approval processes for dealing with this thing. So that's maybe just one on my wish list. I could name a few others.
Yeah, maybe the floor is still open. You can ask your questions. But meanwhile, I have another question, because we have you here from Ørsted and Vattenfall, and I know you are not allowed to tell us anything about numbers, but maybe you have a good, a rough estimate how much money is spent for UXO remediation or UXO clearance in industry in the North, just for the BMU to know about the number.
Yes. Well, I would say a rough estimate for how much money an offshore developer is spending per actual confirmed UXO item is in the millions of euros per one confirmed item.
So that's a lot per item, because this is not on the dump site, right? I will not make it too long here, but maybe I have a last question. So we are talking about that industry is doing UXO, IDNC, and companies like Fugro are doing survey, and you're working for the industry means you have to work with these companies, and then you have the EOD companies who are doing it, getting everything out. And our goals in offshore wind are quite high and increasingly high. Do you think this is still possible to do all these things, or is there any risk you see, especially regarding staff, companies, and resources? That's to you, because
Yes.
you're from the industry, right?
Yes. Yes, I do see a bottleneck in resources if we are expanding with offshore construction the way that it's planned in the European Union. Now I lost my train of thought. Because there's Torsten who wants to ask a question. No. Yeah. If we're doing the same type of survey everywhere, on every cable and every wind farm and every cable connecting every turbine, the same default geophysical surveys, with the size of the wind farms being planned right now and the length of the cables, it is taking too much time. So I know that we have a lot of technical innovations, and that's really helping on increasing our knowledge and improving the way we do the mitigation at the sites. But it's not an endless resource, so it has to be concentrated on the areas that's mostly dangerous and not doing it across the entire North Sea.
Yeah, I do see constraints on resources. When I think about the levels of activity that Fugro has seen over the last few years, and then comparing that with the European sort of ambitions, 2050 ambitions, I don't think that there's capacity in terms of vessels, fleet availability, personnel, assets to keep up with that pace. If we do, because we have to increase the pace to reach those ambitions. So something's got to change. I think that part of the answer lies in learning how to collect more data, but far more efficiently. I think that there could be thoughts along the lines of, instead of just doing single projects, trying to use capacity of scale to collect more data over larger areas that will knock off 4, 5, 6 projects at a time, or development sites, instead of just doing them one by one. It's a little bit less efficient. But then also what Dieter was referring to this morning, there's a massive shortage of EOD expert skills. People who can look at an object and inspect it and understand what they're looking at, and understand the risks that that particular object presents for a project, for a schedule, for people on the site. Those skills are critical in UXO clearance. And without enough people who can do that, all the projects are going to come to a standstill, because you can't run a UXO project without really well experienced and qualified EOD experts. So that one category of personnel is a big problem for our industry.
Thank you. This was exactly what we also heard from Dieter before, Dieter Guldin. But we have another question. Please.
Yes, can you hear me? Yeah, thank you. Thorsten Frey from Geomar. I want to pick up on something that Jann has said like a couple of minutes back regarding, for example, this example of the quality factors that we developed in the BASTA project. And both of you were involved, and as Jann has stated, they were never really picked up. So, I mean, first of all, I didn't like go out of my way that after the project to pursuing and bringing this into industry practice. I don't know what you did, Jann, regarding that, like in terms of sales efforts and whatnot. And there was the pandemic and thousands of reasons, but just taking this as one of many of these examples, like having both of you on the stage, it would be interesting to hear from you, like what needs to happen for you to pick these things up? Like, are you just waiting for a sales pitch of like us asking, we have a new idea and please come to us, or more like an eventish type of thing? So in general, and maybe also going just beyond this one example, how do we facilitate this transfer? What would be your ideal situation to promote this?
Well, I think you're absolutely right. It's very difficult to take research projects and then directly implement them in industry, and it takes a lot of time. It's some of the same topics that we've been dealing with in TenneT, with some of the scientific research that has been conducted and funded by TenneT. It's not really being applied, and there's a lot of knowledge out there. And I don't know if anyone else noticed but me, but no one reads anything anymore. Reports are written about everything, but no one reads them. So we don't really have the time to read and implement, and then we also don't maybe understand everything about one of those scientific projects, and then it's just gone. But it's definitely something that we're working on in TenneT right now, is trying to collect all of that information and actually put it into accessible databases that can be read then by computer software to help us sort out the information, because I think there's too much information out there for the human brain to actually comprehend.
Maybe doesn't add. I think BASTA is a very good example of all of this, because it was one of the, and don't want to criticize no research too much, but it was a very successful research project in terms also of, let's say, the first part of transfer, because industry was involved from the beginning. So we worked together with industry to define quantitative quality metrics actually for data sets. And in the end, it's the question who makes the rules and who controls actually all of this. So, and I think that's, in Germany for sure, we have the big complexity of a federal government with federal states. So we have the 12-mile zone, we have everything what is out there. We have also authorities which have a massive workload. So it's the question if they have the time to deal with this. And Dorthe was just mentioned, there's so much knowledge created. How should they also keep up with this kind of development? And I'm for sure talking about the BSH, for example, who could do something like this. It's a very good question what to do to bring this to life. And I think I don't really have an honest answer. I mean, what can be done is theoretically an industry effort, and I think, Anja, you are thinking about something like this to say, okay, we as industry, we want some standards, so here's an idea of how we can do it as well to bring something forward, because I think everyone is looking for these kind of standards as well. It's not like everyone wants to do their own thing. I think the industry is waiting for something like this. But for sure, it's also something that industry does besides the daily work as well. So no real good answer to this one, but definitely we have a problem there.
Yeah, I see there's another question.
Another question is, you indicate, and it's indicated already quite some occasions here during this day, and I know by fact from my experience that we have lack of experience. There's not enough capacity. It's not there. But where do you guys see to build the capacity? Because we as companies can't build all the capacity which is needed. We have an own education training center, we certify people, etc. We can educate and train you to the right levels and the right standards. But we don't see clients like TenneT or Ørsted or whatever, or Fugro, that often in our education and training. It's the same as with the big dredging companies. I always wonder, why don't you, let's say, start educating and training your own staff to a level that you at least build the capacity, because as you said, you're gonna need it, and you don't build the education and training capacity and the experience just overnight. That takes some time. So does that cross the mind of your organizations to, let's say, let's build the capacity? So you're more independent, you don't have to rely on all these companies which have lack of capacity as well.
That's a good point. From our perspective, we do train our staff, but under the Dutch legislation, the CSOO, it's quite a long process. So yeah, you can train somebody to be a UXO assistant, but what we really need is experienced professionals, experienced senior UXO experts. And to get to that level takes a couple of years, as you know, but it also takes a lot of project exposure. So it's a little bit, you're constrained by the capacity to do work, but you also, it constrains your ability to develop people through the process. I think that there's a lot of scope to work, as Dorthe's previously mentioned, military organizations and partnerships there. I think there's a lot of scope there because those people generally have a lot of experience if they've spent time serving in the military for a while. I think that there's a huge amount we could do with veterans who have worked in that industry before but have, are no longer involved in military activities. I think there's a lot of scope there. But again, that's going to be not a huge pool of resources. I think that there's limitations there as well. I don't know what the exact answer is, but I think that there's a perception, it's not very well known, it's quite niche, so I don't think there's enough publicity around this as a viable career option, if I'm thinking about it in that way. But also, I don't know, we train some of our existing staff members to be assistants on projects with the objective of building them up to become senior UXO experts. That takes time, but it does mean that people have to kind of flip from their current career path and do this in addition, or change their mind and say, okay, now this is a viable path for me, and I'm not sure how many people who are already working in the industry are willing to consider making that their primary sort of career path and dedicate that much time to it that they would reach that level. I think that's a challenge that I see internally.
Okay, I understand what you say, but you could, let's say, divide it in brackets. We can work remote. I do a lot of data interpretation also remote. So if the data collection is done in a proper way, so there you bring the quality, if that's all okay, there you can train and educate people that they at least can confirm that the data collection is all right. We can confirm that as well. And we have also people that don't necessarily need to be on board to, let's say, give you the way forward. So there's solutions to these rules and regulations. And at the moment we are working on new rules and regulations for the offshore for 26 as well.
Yeah, I agree, but we
Maybe
do run
it gives
into
hope.
We do run into some challenges there. Fugro is all about remote as well, and we're trying to remove people from vessels and do as much remote as possible. We normally run into a discussion with clients who want their senior UXO experts on board the vessel. That's a common discussion as well. So there's also a perception in the broader industry. I don't know if you have anything to say on that, but there's a perception in the broader industry that needs to be changed as well, around how much can be done remotely, especially around sensitive topics like UXO, senior work. A lot of people still want them on board the vessels.
Okay, so we have 4 more minutes left, and we have time. Yes, we have time for another question.
Here, because I'm answering directly to your questions. Okay. So Anja Drees from TenneT, and you have been asking what we are doing to support the industry here. So and from TenneT side, I can say, so we internalize a whole lot of the work with regards to UXO clearance. Okay. We do it on our own. We try to really work with the companies on eye level. And because at the end, we are the ones who are having the problem. We are the ones who are driving the energy transition. Our construction timetables, they are short. Our routes are getting longer. And to really get everything in this short time frame is not possible. And throwing this on the market, throwing this at the companies out there is not working. We know that. We are very much aware of it. And we are trying very hard to change the way we are working. For example, with a project that Dorthe has been showing, but we are receiving, every time we change something, we receive also quite a lot of headwind. Instead of just working with us and understanding what we are doing there, it's a bit like, oh shit, now you changed something? Does it mean our business case is gone? So no, it's not. We just changed something. And here I also am trying to account on the creativity of the companies to run with us to achieve the energy transition goals, because UXO is part of it. To mitigate, yes, a very small part, but actually, from everyone who has been working in construction, knows that UXO at the end can always be a weird argument what is used and can really cause delays.
Yeah, well, UXO, I want to add to it, UXO is only a small part of the whole project, but the problem is it starts with the clearance, and if that's obstructed, then you have a big problem in the delay of your project, which, let's say, we think more or less that roughly 10 million euros is needed for, let's say, a full clearance and getting all the UXO out of the area, whatever, based on about 600 million, or what's the investment, 1.2 billion for a windmill. So that's small,
good thing is,
but the time is, let's say, we're always in front, and that disturbs them to the maximum.
Thank you very much. The good thing is that we now have a reception at the end. Terry, I think you will say some words about it, where we all can discuss this in personal discussions. What I learned from this panel was, from this panel was that the industry has a wish, so that the government supports them in destruction or destroying UXO. This was a wish list. That data fusion is a big issue for analyzing all the data we have and for getting better information for good risk assessment. And that stuff is a big issue in the future. And this is also a big issue for the actions of the federal government. And maybe one solution to this was brought up here during the whole day today, was that a wet storage, a short-time wet storage, could be one part of a solution. So at this point, I would like to close the panel, and I think, Terry, you will give some words to us, and thank you very much to the speakers here. Thank you to you.
Thank you very much, Peter. Yeah, I'm just a couple of words to wrap us up and set us off into the evening. We do have a reception happening where we had lunch today and networking in the exhibition area. On our program, there's a reference to a guided exhibition tour. We've decided to scrap that. The exhibition there is pretty accessible, and everyone just wants to walk around and talk and look at things on their own anyway, so we're going to do it that way. One addition to the exhibition that is really important and that you might enjoy is actually not in the exhibition hall. It is too big and too heavy to get into the hall. It's out in the parking lot, and it's only going to be there until 3 o'clock tomorrow afternoon. So it's really worth going out to see it. It is the Gray Shark. I went out and looked at it during lunch. It's from Euro Atlas. It's an autonomous underwater vehicle, but it is an unusual autonomous underwater vehicle, both because it's very big and it's very agile and very heavy. But it's worth looking at, and there's a gentleman there who can explain to you exactly what makes it important and interesting. So yeah, I encourage you to do that. And I think that's about it for today. We're going to be back here in the morning. We begin at 9:10. We've got lot of super interesting stuff happening tomorrow. Thanks to everyone who participated today, and I hope to see you in the networking session just now. Thank you all.